Good morning, sir.
Hello, sir. Good
Hello.
morning, sir. Am I audible?
Yes, yes, audible, sir. You are audible. So, dear friends, now we are having Sri Hitesh Solanki ji. He is a scientist C in Inflibnet, Gandhinagar, Gujrat. Inflibnet is Information and Library Network. So we all are aware of what Inflibnet is. He is scientist C, and he used to conduct many workshops in many places. So today I requested him to talk about statistical and exploratory data analysis using Jamovi. Jamovi is a software which is based on R, and it's free, so open source, so you can download it free and you can use it. There are many modules of this, so he will introduce all those things. I'm also not much aware about this software, so I cannot tell much about this. Many things I used to say, once again, earlier also I told him that many a time for social science teachers, statistics is a zombie, and Jamovi is there to kill that zombie. So now time is yours, sir. You can take over from here. And we are having some 35, 34 participants, and all are faculty members in different colleges and universities. They are representing some 14 states, and most of them are PhD. Some still one third are pursuing their PhD. They are still ongoing, and they belong to commerce, economics, and management. So, sir, now time is yours. You may start, sir. Unmute, sir. Unmute.
Just a minute.
Guys.
Shall I share my screen?
Yes, yes, sir. Yes.
Hope is it visible to you? I think it is visible.
Yes, yes.
Okay.
Uh,
Okay, fine, sir.
yes, yes. Some black
Thank
patch,
you, sir, for yeah.
some two black patches are coming. Is it part of your slide or something else?
Yes. Uh, like this.
Yeah, yeah. Still, it is on top. If you see this box, on top, one black box is coming. I don't know. It is coming only for me or some dialog box is
Now,
okay. Now gone. Now gone. One below
uh,
corner also is there. Left corner. Yeah,
acha,
yeah. This one. Yes, this one.
this
Okay.
is annotated.
Okay. Fine, fine. No
This is
problem.
the default features of that.
Okay, fine, fine. Continues.
So, thank you, sir, for giving opportunity to share statistical and exploratory data analysis using Jamovi in this refresher course. Uh, Let me start a brief introduction about basic concept of the statistics. As you are aware about, data is nowadays not only numbers, but it can be measured in a different graphs, different observation, different facts, even whatever we are getting in social media. So that is also now treated as a uh, data only. Even whatever we are capturing through video, any lectures, any images, CCTV, everything can be considered as a data. So data is a collection of fact or information which can be used to derive conclusion from that raw informations. Okay, so as you are aware, and we learn also in our higher education, okay, there are different types of data. So basically, it is categorized as a qualitative data and quantitative data. Qualitative, you may alternatively say attribute data, means the data which can have a some non-numeric characteristics, just like gender, male, female, state of birth, condition of patient, word, images, video, everything can be categorized in one or more different groups, just like result or divisions of students. So just like distinction, first class, second class, and so on. Quantitative, the data can be studied. The characteristics being studied in numeric form. So just like exact number, percentage of the marks, age of the students, number of blood, WBC in a blood sample. So such kinds of variables can be categorized in a quantitative form. Same way, when we deal with quantitative, so it may be available in either whole number or continuous number. Whole number, that means which can be easily just countable. Yes, just like a number of pregnancy, number of missing teeth in a children, number of visit made by doctor, number of goals in a football match. So which can be described, which have a that particular range of value will have a small small size, whereas continuous variable will have a n number of observation can fall into that particular range which is defined for particular variable that can be considered as a continuous, just like a height of the athletics or weight of a boxer. So weight may be start from 70 to 150. In between, you may have any number of observations, 71.51, 72.580, like this, and number of. So similar example also given just like serum cholesterol or blood pressure. So in a nutshell, you will have a types of variable. It will be qualitative and quantitative. Qualitative, that means only category, just like brand of PC, Dell, HP, Lenovo, Acer. Marital status, unmarried, married, divorced, widow, just like hair color, brown, black, bluish, brownish, reddish brown, like this. Quantitative, discrete and continuous. Discrete, that means we'll have a very small set of observations, just like children in a family, strokes in a golf, TV set home, either one, two, three, or four, not more than five or not more than 10, like this. Continuous, just like amount of income tax, weight, and yearly rainfall in particular state or like this. So this is the glimpses of previous three slides. Same way when we are dealing with uh, observations, so always we need to take care of at which measures level we need to measure our observation. So there is a highest level of measurement is ratio. Okay, but initial basic level is nominal. Nominal always fall into this or that, like this, either this or that. Ordinal will have a some order. The interval which represent value but not actual value, that, and ratio that will represent actual value. So let me explain detail. In nominal, observation of qualitative variable can only be classified, counted or not counted. It satisfy either equal to or not equal to, just like blood group. Your blood group is either AB or B or A. Any one of the group, like this. Marital status, either married, unmarried, widow, like this. Okay. So this is where it is satisfy only equal to, not equal to. Whereas ordinal level data will have a not only equal to, does not equal to, but greater than, less than also would be there. There is a order, some order will, just like high, medium, low will have. Just like you can easily understand by this picture, the chili, hot, hotter, hottest. So naturally, hottest will have a superiority than hotter and hot. So similarly, which each group, hot, hotter, and hottest have a some specific order. So this will next level, then nominal. So this is ordinal level data. Usually we are taking when we are conducting a survey, we used to ask question for any favor or opinion. So whether this person is favoring this question or this, how strongly believe this. So we are used to use this strongly agree, neutral, disagree. So this is the type of ordinal type of data. Interval level data. Interval level data, actually, when we are purchasing any shirts or dress size, it depends on three different parameters: bust, waist, and hips. Okay, so it is, this size is depends on, just like if you are going for size A, then bust is 32 inch, 24, and 35. As you are increasing here to 8 to 10, so each parameter will have an increment by 2. So naturally, for 10 to 12, again 2, 12 to 14, again you are getting 2, 2, 2 in each parameter. But 8 to 16, so it is going to double from here 8 to 16, 8 to the 16, but not it is going to be 32 to the 64. So this is interval data, whereas this number does not represent actual value of that number. So here equal to, not only equal to or less than or greater than, but here addition and subtraction property going to satisfy, and such data classification o- are also ordered, but it does not belong into qualitative type, but it is considered in a quantitative, but it is interval level of data. The highest level is ratio level, where all the numeric only previous all the properties or characteristics here, but here multiply and division also would be considered here. So such kinds of weight or circumference, height, temperature, all would be considered in a ratio level data. So based on this previous four slide, what we consider, so where categories but no order, that is nominal, categories or there is a order, so ordinal, difference between measurement but not true zero, so that is interval, and difference between measurement true zero exists, that is ratio. So these are the four different level we can observe the data before analysis. So why it is important? Because before going to, when you go for any kind of SPSS or R or Jamovi, any software, you need to define the list of variable used during analysis and at which level you measured this, that also need to be explicitly specified. So that's what before analysis we need to use this. That's what I am here explaining this. Okay. So level of measurements as the these four levels. So data may not be uh, data may only be classified. Okay, just like car, make model of car, jersey number of football player. So that would be considered either this brand particular, either it is from Nike, either it is from Puma or like this, or Adidas like this. Okay. Ordinal, where your whatever you can, ordinal, just like our division of students. Either they obtain distinction, either they obtain first class, second class, pass class. So such kinds of data can be uh, classified in a ordinal or can be measured at ordinal. Temperature, just like zero is does not, 0 degree is does not represent actual value zero here. Even dress height or shirt size, that can be considered in a interval. And ratio, rest of the any other meaningful data value which represent actual that value, that can be considered as a ratio. So now just a quick exercise for you. Just age, mother's age in a year. So decide which level we can measure. You your answer in chat box. Hello, nobody is there.
Yeah, yeah, I'm here still. Oh, yeah, actually, sir, our participants are not having access to audio. So they can
Okay,
put,
not but they are able to give answer in chat box.
yeah, yeah, chat box they can write, yes. Ordinal, someone is writing.
Okay, mother's age in a year.
Mother's age is not ordinal,
Ah, not ordinal.
it is,
Ordinal Nominal and ordinal always comes for categorical data. I am not asking this discrete or continuous.
Ratio.
Ratio only, correct. Weight of infant at the time of birth. Weight means level. I am asking measures of level of measurement. Nominal, ordinal, interval, or ratio. Weight is ratio. Okay. Weight is ratio. Father's religion. Father's religion. It is categorized in a one, two, three, four. Nominal. Very good. Smoking status. Nominal. Very good. Labor pain. Labor pain. Labor pain. Ordinal. Very good. History of hypertension. History of hypertension is not a nominal only. Yes or no? Number of physician visit during hospitalization. Number of it is ratio. Okay, but it can be considered in a level is ratio, but which type of variable then discrete. Correct. Program feedback. Program feedback belongs to ordinal. Very good. Okay. Let me resume my presentation. Now, in statistics, there are, as you are aware, there are two types of statistics, descriptive statistics and inferential statistics. So, I am not going to detail description about this, all the presentation, but just you, for your better understanding, I just prepared few slides where you can understand easily. There is a type of variable, whether it is scale. Scale means either you may use continuous, you may use scale. It depends on your statistical package terminology. Okay. So if it is normally distributed, then you can go for mean and standard deviation. If it is not normally distributed, skewed data, then you should go for a median and interquartile range. When same as categorical, you have another two options. Either your data is nominal, then you should go for mode. There is no uh, measures of dispersals would be there. And here, if it is ordinal, then median would be the measures of central tendency, whereas interquartile range would become appropriate your measures of dispersion. So be clear about these things when you go for any statistical analysis. How to identify your summary statistics or measures of central tendency and measures of dispersion that can be used based on type of variable as well as which type, how your data spreads out. Okay, if it is normal, then mean and standard deviation. If it is not normal, then median and interquartile. Similarly, for quartile. Similarly, various types of charts are would be useful during your analysis, but it is very important which chart is useful when based. That is also depends on your nature of the data. So, so these are the charts which is you frequently use, but one this chart is most important, that is known as a box whisker plot. Okay, so it gives a out of box information. The whisker plot is also known as a box plot diagram, which gives a 5 number summary. Okay, so this yellow vertical line shows the median of the data. This line shows the first quartile of the data. This is third quartile of the data. This is non-outlier maximum number. This black vertical line shows not outlier minimum number, and out of the range any point appears. So that can be considered as a outlier, so which is available in a set of observation. And whatever the distance between Q3 minus Q1, this distance is known as a interquartile range, which is also one of the measures of dispersions under this. Okay. So this one plot itself gives a lot of information. So this plot is very much important while plotting before analysis. You need to describe your data in this plot. Okay. Now, again, I told based on the nature of the data, it is you have to judge okay, which graph I need to plot. So if you have only one variable and which is continuous, so you should go for histogram. If you have only one variable and that is categorical, so either you may go for bar diagram or pie diagram. Okay. So there is a difference between histogram and bar diagram. Bar diagram in x-axis will have a category, whereas histogram will have a variables. Okay. Y-axis will have a number of that value for each particular groups, where here frequency would be there. So there is a difference between bar and histogram. When you will have a two variable and both types of variables are continuous, then you should go for scattered plot. Whereas one variable is scale and second one is categorical. So either you should go for box plot diagram. You should go for box plot diagram. And both variable are categorical. So either you may go for multiple bar diagram or stack uh, stack bar diagram. So this is the way you may use as per your nature of the data which is being considered in your analysis. According to that, you need to choose appropriate graphs for interpretation or presentation of your data in a graph. Now again, quick exercise for you. Now you can put your answer in chat box. Where is chat? Okay. Decide type of graph, gender. Gender. Which graph is appropriate? Bar is okay. Okay, fine. But I think only two attributes. So we may plot with pi also. Okay. Restaurant feedback. That is again bar. Amount. Be careful here. Amount, not line. Line should have a two variable. Here only one variable. No pi. Pi is only for categorical. Scattered, no scattered. Frequency, little bit very close to answer. What I only one variable. Go back to my slide. This na only one variable. Okay, and amount is a scale. So which one? histogram. Then here gold price and sales per day. Box plot only for one variable is categorical and second one is scale. Then you can go for box plot. Gold price is again scale. Sales per day, that is also scale. That is also scale. Okay. So in that case, you can go for scattered. Okay, fine. Okay. Let me move forward. Okay. So this is the way you can choose appropriate graph for this. Okay. So before starting my uh, actual presentation, I just would like to recall these things because it will be helpful to you while selection of this. Now, I'm not deep dive into this portion, but I will directly takeaways the statistical hypothesis. Sorry. So, what is the statistical hypothesis? So, taste of hypothesis is nothing but whatever you are going to collect the observations, and based on that, you have a some central value, you will have a some dispersal value, and that you are going to estimate based on population. So whatever you collect the sample that is at par with your population, that you are going to derive. This is called the testing of hypothesis procedure. Now this is not only for mean, various statistical tests can be implemented here. So testing single mean, testing single proportion, testing single standard deviation, two standard deviation, comparing of two sample, comparing of two more than two samples, and many testing. Even not only this sample, but correlation, regression coefficient also can be tested here. So this is the beautiful workflow I designed here for deciding which test is appropriate in according to that nature of the data. Okay. So first of all, you should start with your problem. Is this problem a test for means or proportion? So what is your objective? According to this, you need to decide. It is related to means or proportion. Means when you will have a data related to quantitative, then you will have a means related problem. If your data is related to qualitative or categorical, your problem move towards to proportion. Now this, is this test for single mean or difference in mean? Have you collected one sample or multiple sample? Okay. So that is related single. Okay. And if it is multiple, then you need to move towards the right side. If it is single sample, then are you aware the standardization? If it is yes, then go for J test. If it is no, then go for T test. If you have a two sample, then you will naturally call difference between male height is equal to female height, or first year student's height is equal to second year student height, or one height of the one college is equal to height of the students of belonging into second college. So two, whenever you will have a two sample, then you will going to identify the difference between particular parameter. Now there is again question. If you have a two parameters, two samples, then whether it is dependent or independent. If it is independent, again it will lies into sigma or standard deviation known, then Z. If it is not known, then T. If it is dependent, then you will go for T test for dependent population mean. Okay. So what we are here doing, so whatever we have collected the sample and the sample mean is X bar. And based on that, we are trying to estimate the population mean mu. Okay, sample mean is always denoted by X bar, population mean always denoted by mu, sample standard deviation denoted by S, population standard deviation denoted by sigma. Okay, similarly, if it is qualitative related problem, means categorical data is there. If it is single, then Z test for population, proportion and difference, then difference in population proportion for Z test will be used. Okay, so this is the ideal scenario how to decide the which test is applicable. Will I will explain it more in through illustration. We'll see later. Alternatively, you can use which test is applicable. This is the way also you can identify. Now, every time when we cannot directly use t-test in all the circumstances, okay, it depends on the nature of the data, which data follows normal distribution or not. Your data is quantitative as well as it follows normal distribution, then your problem is related to comparing the mean. Means your hypothesis is like mu equal to some value, mu equal to 12, mu equal to 6, mu equal to 150 centimeter in case of high. Okay. So mu equal to mu 0, whereas alternative mu does not equal to mu 0. So one sample t test will be used. If you have two sample, naturally average height of college student 1 equal to average height of college student 2. So both you are going to compare. So mu 1 equal to mu 2, whereas mu 1 does not equal to mu 2. Such cases, two sample t-test would be used. If beyond the two sample, you need to jump to the ANOVA. Okay. Now, what is the situation when you do not have normality or your data does not follow the normality assumption? So you should directly jump to the Wilcoxon test in case of one sample. Your data is continuous, but it follows not normal. It does not follow normal distribution. It is non-normal data. So you cannot directly apply two sample t-test. Instead of that, you have to apply man-Whitney test. Okay. So same way, ANOVA only applicable when your data will have a more than two sample. It is continuous as well as it should follow normality assumption. Then and then you can apply ANOVA. Otherwise, if these certain assumptions are not satisfied for your data, you should jump to the Kruskal-Wallis test. Okay, so such a way you need to decide based on your the data. You directly cannot apply t-test on your observation without checking the assumptions which is defined for one-way ANOVA, two-way ANOVA, one sample t-test, two independent sample t-test, or dependent or pair t-test. Okay. So be careful when you apply any test of hypothesis, especially in parametric test. You need to clearly satisfy the assumption first, then and then you can go for t-test or any parametric test. Whether are you using Stata, are you using SPSS, are you using Jamovi, whatever. These rule become a thumb rule for all kind of software. Okay, it does not matter. Okay, SPSS give directly for that, so I directly jump to this. Okay, let me take one simple illustration for t-test for me. So there is a only five step need to be remembered for any kind of test of hypothesis. Step number one, set up null hypothesis. Okay. In case of single mean, your hypothesis always mu equal to mu zero, where mu zero would be any scalar or any value, number would be always number. Okay. Alternate, either it may be mu does not equal to mu zero, or greater than mu zero, or mu less than any one. This it depends on your objective. Okay. After setting of null and alternative, third step is very much important, and that is assumption. Okay, how to check assumption? So there is a assumption is कि वो population from which sample drawn it assumed as a normal distribution. So how do you satisfy this assumption? So there is a two way. Either you can go for graphical methods or by using test of hypothesis. So graphical method, there is three different plot can be used. One is histogram, second one is box plot, and third one is QQ plot. By using these three, we can have a rough idea about our data, whether our data follows the normal distribution or not. But accurately, significantly, we can say only by using Shapiro-Wilks test only. Okay, okay, whether our data follows normal distribution or not. So before applying t-test, first of all, we need to check the Shapiro-Wilks test by using Shapiro-Wilks test. We need to prove whether data follows normal distribution or not. If it is follows, then we can go for t-test, and when you apply t-test, you will have a p-value, and based on p-value, you have to conclude p less than or equal to alpha level of significance, means either it is 5% or 1%. 1% means 0.01, 5% means 0.05. So if it is 0.05, p value is less than or equal to 0.05, you have to reject null hypothesis. If it is more than 0.05, so we fail to reject null hypothesis. So this is the thumb rule for all kinds of test of hypothesis. Okay. So these five steps you need to remember. First one is null hypothesis. Second one is alternate hypothesis. Third one is assumption. Fourth one is applying t-test, and for fifth one is conclusion. Okay, let us take one example. Read carefully example. Based on field experiments, a new variety of green gram is expected to give an average yield of 12 quintals per hectare. The variety was tested on 10 randomly selected farmers' yield. Okay. So what we have a observation, what is our variable, decision variable here? Yield. Okay. Yield of yield per hectare. Okay. So how many field we have? 10 from different 10 farmers field we have collected observation. Okay. So yield per hectare from field number 1, which have 14.3, second 12.6, 13.7, as so on, we collected from 10 different fields. Okay. What is our expectation? Okay. What is our interest? So our interest is average yield. Average yield is population yield. Okay. So population mean is mu, which is equal to how much our expectation? 12. Okay. So mu equal to 12. So according to hypothesis, how many steps? Five step. Step number one is set up null hypothesis. Okay. And step number two is alternate hypothesis. Okay. So let me set first null hypothesis. Okay. So step number one, null hypothesis mu equal to that average yield is quintal per hectare. Okay. So what would be the alternative? So alternative hypothesis is mu does not equal to 12. Okay. Now this. Just a minute. Okay. So alternative is mu does not equal to 12. Okay. So average yield is not 12 quintals per hectare. Okay. Now, how to apply? Third step is normality check. Okay. So now you require some software. After setting of null hypothesis and alternate hypothesis, you require software. Now you are going for Jamovi, let's say. So what you require? Okay. So in my system, I already installed Jamovi. I already installed Jamovi. Okay. Just like Excel. Okay. Now before using this, my screen is visible apart from this.
Yes, sir, it is visible.
Okay, fine. Now, how to download Jamovi? So, just in Google, you go to the Jamovi download for Windows. Okay, there is a one official website, jamovi.org, where you can have a Jamovi desktop and Jamovi desktop version, where you will have a solid means stable, and this is latest. We have a latest version, but no, it is under beta version. So I recommend to go with solid, where you will does not have any error. Okay, and according to your type of OS, you need to select the file exe and simply next. Okay, once it is downloaded, then you just open that file and click next. Okay, you will get a installation in your local system. But meanwhile, when you install Jamovi and click next, it will ask, "Okay, which R version you would like to choose for that." So first of all, you need to install R first and then install Jamovi. Be careful. First, you need to download R, okay, for your system. You installed it, and after that, you install Jamovi. Then it works fine. Okay. Now, once it is installed in your system, Jamovi, you search in your all program Jamovi. Okay. It looks like a little bit Excel. Okay. This is data sheet. This is data sheet. This is menu, variable, data, analysis, edit. This four tab default would be there. This is the variable, just like SPSS. Okay. In background, R command will be executed. Okay. So just like whatever variable you would like to put here, you can just rename. Once you select that and add it, you can rename the just like roll number. Okay, roll number is kind of identity. Okay, and which data type it is integer I have given, let's say. Okay, next is marks. Okay, marks is continuous, nominal or ordinal, continuous. Okay, and it is type of integer only, whole number would be there. Okay, and third one is, let's say, students gender. Okay, so whether it is gender belongs to nominal or ordinal, nominal. Okay, so where we can define one is a value for male, two for female. So such a way we can define labels along with its label. Okay, so I am using here three variable. One is identifier, one is continuous variable, and one is nominal. Now I just jump to this. Okay, three column is there. Roll number 1, 2, 3, 4, 5, 6, like this. Okay, marks obtained is 89, 45, 3. Okay, like this I can enter. One is for male, two for female, male, female, female, male. Okay, so such a way we can prepare our data here. Okay, even not only this is the you can create a n number of variables and you can input the data in this. Okay, before applying any kind of analysis. So first two tab is related to data and entering and data processing part. Okay, you can transport a new variable, you can compute another variable, you can delete the variable, you can add the variable. Everything features would be available in this data and variable. Even you can save this file by using this, or wherever you would like to save, just like I would like to save on desktop the T1. Okay, so it will be saved here. Okay, tomorrow you can open this file and you can further process whatever remaining, you can go ahead with this. Okay, so this is the way you can create a file. Now your data is already available in somewhere, some file. Just like in our example, our data is already given in a greengram.xls. Now let me open greengram.xls, which is already available. Yes. Here, whatever 10 observation there, I kept here this 10 observation here, and I have given the name. And which type of variable this? Continuous or what is called categorical. It is continuous variable which is observed in a numbers. Okay, so let me open this file in, if your data is already organized in any any excel csv spss file, so that also can be directly imported, sorry, directly imported. Again, let me again show Jamovi. Okay, how to import this? So if you have a, first you need to open this Jamovi. Go to here, open where green gram Excel. Okay, once you open, it is automatically data filled in a data sets, data sheets, and only one variable which is continuous type of variable. Okay, now as now you understand this variable and data, now let me move to the analysis part. First of all, whenever you go for any kind of analysis, you just first understand the structure of the data, okay? And how data, what is the central value of the data and how data spread out, means measures of dispersals, okay? So you go with this exploration where first of all there is the option descriptive analysis or descriptive, summary descriptives. You just find out. Okay. Once you click here, your tab would be available. Your screen would be divided into three parts, one, two, and three. Okay. One, two, and three. Earlier, I did not uh, praise this exploration. It was only two part. One is dataset and this is output window. Okay, but once I clicked here, there it is vertically divided into these three. Okay, the which variable you would like to find out the descriptive statistics, select that variable. In fact, we have only one variable, but if you import for your PhD data or your research work data, we'll have a multiple questions and multiple variable would be available in a one seed. Okay, so here we have only one variable, so that we are going to consider for finding the descriptive. So once I move here, automatically how many number of observations are there, what is the mean, median, okay, standard deviation, minimum, maximum, everything would be cal- calculated here. Now, if you would like to create a histogram for this variable, okay, you will get, just check. Okay, histogram is created for that. If you would like to create box plot, you just check, click on box plot. Automatically, this output, dynamic output would be generated. Okay, this is bar plot, but bar plot is not applicable here because our variable is our variable is quantitative. If you would like to create a density, okay, so see density with histogram. Okay, now if you would like to create a QQ plot, once I click here, QQ plot also will be attached here. Okay, so such a way you can create, you can create graph as well as you can summarize your descriptive measures of central tendency as well as measures of dispersion here. Okay, by using this function. Now come back to our problems where we need to check with normality check. Okay, whether this data follows normal distribution or not. So under that, there are two methods I mentioned. There are graphically we can say by using histogram, box plot, and QQ plot. Okay, our roughly we can say okay, our data follows normal distribution or not. Okay, so just like if your this median point is uh, little bit center part of your box plot, that means your data follows normal distribution. QQ plot, based on QQ plot, your observations is close to this reference line. That means your data follows normal distribution, not standard normal, but normal. Okay. If you are getting some bell-shaped curve in your histogram, then you can easily, roughly say your data follows normal distribution. But we can significantly say normal distribution only if when we apply Shapiro-Wilks test. Okay, Shapiro-Wilks test. Okay, apart from this, in statistics, many more default, not only this, but many more different dispersions also, if you would like to calculate. So that is also possible. You need to just here check. Okay. So by using this, you can calculate this, any measures of central tendency as well as measures of dispersion. Now, let me open. This problem is related to one sample. Okay. So one sample t-test. One sample t-test. On which variable you are going to apply t-test? Yield Okay. Now, first of all, you need to which value, what is your mu? Mu equal to 12. Okay. So what would be here test value mu equal to 12 you need to put here. Okay. Now assumption check. Okay. So by default, this software gives up functionality. Okay, when you apply the test of hypothesis, no need to remember the assumptions for particular. Once you apply t-test, okay, you apply your according to your hypothesis mu equal to 12. Okay, alternate is does not equal to test value. That is okay. Now, which assumption you need to check first, then this result will be applicable there. So, normality test and QQ plot. Okay. So, based on this, based on this, you need to finalize or conclude your result just like 0.891. Okay. So, what I mentioned here, 0.891 is my p value for normality, which is more than zero point zero 0.05. Okay. So this is also test of hypothesis. And hypothesis should not have any bias. So Shapiro-Wilk test, our hypothesis would be data follows normal distribution. Against data does not follow normal distribution. That would be the null hypothesis for normality Shapiro-Wilk test. Here 0.891 is greater than 0.05, which shows, let me go back to, sorry, huh. P value is greater than alpha, we fail to reject null hypothesis. Okay, so here we fail to reject null hypothesis, where our null hypothesis was data follows normal distribution. Means ultimately we need to accept our data follows normal distribution. Okay. Now, once it is accepted, okay, then we can use this t-test result. Okay. Now, our according to this null hypothesis is mu equal to 12, and here value of t value is 1.8 and p value for one sample t test is zero point 0.1. Okay, zero point 0.1. That means we fail to reject null hypothesis at 5% level of significance. That means new variety of green gram is expected to give yield 12 quintal per hectare. Okay. So this is the way we can use Jamovi to check or to apply test of hypothesis for one sample T test. Okay. If you have any query, either you may ask later or if you have any question, I will give you 2 minutes for this illustration. Then onwards, I will go for two independent sample T test. You can put your question in chat box. Okay, fine. Now, let me explain another problems. Okay, I think this is also related to one sample only. Okay, so this is, let me skip, I will go to the first. This is for your exercise, example 2. Hmm. Now, see, when you will have a two independent sample, suppose, for example, I am interested to find out the average height of the students. Okay, so there is a one case. I will collect the height for all the students. There is no any specific college, region, state, country defined here. Okay, defined. But universally, I am interested average height of the student. So only one sample. I will go for height equal to particular expected height means 160 centimeter or not like this only. Whereas when you are going, okay, height of the Mizoram University student is equal to height of the Nehu students. Then you will have a two university and two university students. So both are separately or independently distributed. And in such a case, you will go for two independent sample. Okay. And same way, I am adding one more. Height of the Mizoram University students, height of the Nehu students, and height of the Guwahati students. Okay, Guwahati University students. Then we'll have a three sample. So more than two sample. So you will go for a ANOVA. Okay, but condition apply. All assumptions should be satisfied, just like normality. Okay. So here only, but when you have a two independent sample, naturally you will have a comparison of these two, difference between these two. So null hypothesis equal to average height of the Mizoram University is equal to average height of the NEHU students. Alternative does not equal to either greater than or less than. Okay, like this. Now, first, once you set up for a null hypothesis and alternative, you will go for assumption. Okay. Now here, the assumption is both sample should be drawn from population and it should be normally distributed. And that can be checked by using QQ plot or Shapiro-Wilks test. And two population variants are unequal, unknown whether it is equal or unequal. Okay, that can be used. Okay, now here we have a two sample. So the variance, population variance are equal or unequal that we need to check here. Okay, so and so all cases, these five steps will remain same. First, step one, null hypothesis. Step two, alternate. Step three is assumption. Assumption may be varied, depends on the case to case. For one sample, assumptions are different. Two independent sample, assumptions different. Pair t-test assumptions different. Okay. Again, step number 4 and 5 would remain same. Test statistics and p-value, and based on step number 4, you can conclude your result with respect to p less than or equal to alpha means 0.05 in case of 5% level we reject null hypothesis or either cases we fail to reject null hypothesis. Okay. Now this is the formula when it will have a equal variance such kinds of t test formula will be used when it will have a unequal variance then Welch t-test would be the. So if your it is giving equal variance, then student t-test and unequal variance, Wells t-test would be used. Okay. So here another example given here, fertilizer trial, gra- grain yield of paddy was observed as follows. Okay. Now we have two sample, but sample is characterized How? Based on the fertilizer used, ammonium chloride used in that particular field, and one urea used as a fertilizer in particular field. So what is the yield of paddy observed here, that is categorized as a two different sample. So five observation taken from the field where ammonium chloride was used, and how many? Eight observe seven observation collected from sample where urea was used. Okay. Now, is there any difference between source of nitrogen? Okay. So, is there any impact or difference between these two fertilizer? Ultimately, we are going to find out. So, average yield of this is equal to, what is our null hypothesis? Mu1 equal to mu2. Okay. Now, as I told you, null hypothesis should not have any bias. So there is no significant difference between source of nitrogen in both fertilizer. Okay. Alternative, there is a significant difference between source of nitrogen. Okay. Like this. Now, it just now let me open the screen fertilizer.exe. Fertilizer.xls. Now, see, when you such kinds of preparing data for this, it is human readable format is given here. Okay, these one, two, three, four, five, and this seven. Total 12 observation, human readable format easily given. But when you organize your data in any statistical package, so it should be clearly required by package. Okay. So what this is ultimately what is your variables. Okay. Yield. This 42 kilo per plot yield, 39 kilo per plot yield, 38. Okay. These numbers, whichever mention is two digit, that is yield. So your first variable is yield and second variable where you obtain 42 when ammonium chloride. So there are criterion variable is two, that is fertilizer. One is ammonium chloride and second one is urea. So in variable list, you should have a this yield and fertilizer. Okay, yield and fertilizer. Whereas yield is a which type of variable? Yield is a continuous variable. Okay, and fertilizer is your category variable, either ammonium chloride or second one is urea. Okay, so once you need to set up this, you can directly input the data here or directly import from Excel or CSV file, but your data should be arranged like this, not first column for ammonium and second column for urea like this. Okay, this is single column which provides the yield of production, and second which is categorized or what is called, which is splitted according to fertilizer or subgroup. Okay, now go for analysis where you may have a independent sample test. Okay. Now I am directly here jump to this portion. Okay. Because later stage we will consider the assumptions also. Okay. Now which variable you are considering? Yield is depends on fertilizer. Correct? Yield is depends on fertilizer. So who is the dependent variable? Yield. Okay. And who is, how can you distinguish these two based on fertilizer? How can you make a group number one and number two? Okay, so fertilizer become a grouping variable. Okay, now this is your P value for your output. Okay, this is your P value of output. Now see, this is wealth. Now there are two T student t-test and Wells t-test. They provides both p-value. Okay, they provide both p-value. Now, which p-value we need to consider for our result? It depends on our assumption. Okay, first of all, we'll check for normality. Okay, Shapiro-Wilks test for yield, which is p-value is 0.05, is more than 0.05. That means our data follows normal distribution. You can check with QQ plot also. That is also close to, so not a issue. It is clearly mentioned, means we can judge based on this Shapiro-Wilks test. Our data follows normal distribution. Okay. Then what other condition was there? Assumptions for huh, two population variance are equally. So that can be homogeneity test can be applied. Here p-value is less than 0.05. That means both both samples are having equal variance that we assume, and we are going to reject this because p-value is less than 0.05. That means which case we may use this Wells t-test as a for final. So out of this, if it equal, then student test t-test will be used. If it is not equal, then Wells t-test we use for interpretation. Just like here I mentioned this t test for equal variance, t test for unequal variance. Okay. So out of this, suppose our data does not follows normal distribution, then this man-Whitney test will be used. Okay. So in single interface, you will have a parametric flavor also, non-parametric flavor. You just check all these three. Okay. But while interpretation, you need to be careful. If it is your data is follows normal distribution, so ignore man-Whitney. These two would be useful. Under that, your assumptions check. Homogeneity test gives either equal variance, your sample have a equal variance. Okay. Then student t-test, your sample does not have a equal variance, means unequal variance. Then Wells t-test. Okay. So here our sample show does not have a equal variance here. Okay. So we'll go for this p-value for interpretation. Okay. So here p-value is again 0.05, which is less than 0.05. So whatever we assumed here, if there is no difference in source of nitrogen in this both fertilizer. So that we are going to reject. There is some significant difference between source between these two fertilizer, so that that we can significantly conclude here by using this test of hypothesis using this. Similarly, you may use any kind of just like pair test. In such which scenario you can use pair t-test. So before after condition, just like for example today's live example, like okay, before share. Before starting of my Jamovi session, I conducted 10 questions exam. Okay, 10 MCQ question. And I asked something about Jamovi. Okay. And after this session, I will ask again about Jamovi 10. So this before session, after session. And I want to check with okay, whatever I conducted session that is fruitful for you. Okay. But in both cases, that attendees are remains same. Okay. Not like this. Okay. I conducted exam some other class and I took session in class X and I examine again after session in class Y like this. In both scenario, before after scenario, the participation or that attendee would remain same. Just like before fasting sugar, after fasting sugar. Okay. But that patient would remain same. So such a case. So before and after in both case that sample that participant is same are same, so that's what it is known as a dependent t-test or pair t-test. Okay, so whereas two sample that means either they are independent, either they are dependent. If they are dependent, you can go for paired sample t-test. If they are independent, you can go for independent. If it is, sorry, if it is more than these three sample, then you can go for ANOVA. Okay. So I am not taking, due to time constraint, I am not taking more example here, but this is the related to glimpses of Jamovi. How can you use this Jamovi? It is very easy. It is looks like appearance or graphical user interface look like SPSS, and the most beautiful part of this, okay, in SPSS, if you remove any one of the observation, you need to perform all the steps again and again. Whereas, just like I am changing here, instead of two, I place one. Automatically, your output dynamically regenerate. No need to perform again steps. Whereas SPSS, any single correction you made in your data set, you need to perform all the steps again, just like click here, then independent sample test, and like this, you need to perform. Whereas here, no need to perform like this. Suppose I am putting this instead of one, I am placing here two. Automatically, see, you can observe it is value is going to be changed. Here, see, instead of 39, I am placing here 40. Automatically, value becomes changed. Suppose 59, automatically p value and all going to be changed. So it is very beautiful software and it is ultimately graphical user interface of our environment where many those who are not coming from means technical background they naturally will have a means fear to use or do not have a programming knowledge, they used to avoid, but now it is introduced for non-coder non-programming community. Okay, even apart from this, if you want to add any new module which is not available, so just like your Play Store, you can add any required your package means by placing this any just like power analysis of common research design or many packages just like this structure equation modeling. So whatever if you would like to add, just like survey plots, okay, if you would like to add here, so you can install, that will be integrated in your, see, this, it is added here. Okay. So these are many packages available which can be add, which can be add explicitly by using this plus two sign, sorry, plus sign. Okay. So with this brief introduction about uh, Jamovi, conclude my presentation here. If you have any query, you please feel free to ask. Sir, your,
You kept on taking questions in between, I think. Responses you
yeah,
kept on getting. So there is nothing like this. But friends, just put your question in chat box or Q&A box. They are asking for your PPT.
sure.
So you can send it
I
to
will
me and
share.
I will share with them.
Sure, sure.
This was a nice presentation, sir. Interesting.
Thank you, sir. If you have any query, we used to conduct a 3 days workshop on this.
Okay.
Usually, this year I could not conduct due to some other engagement. But if you have any query, you just contact me. This is free, no subscription. It is open source, developed in open source, and it is. I shared my contact number in chat box.
Okay.
This is my WhatsApp number, and this is my email ID.
Your email
You
ID
can
already
con-
they have, sir.
Okay.
In program sheet, all
So
email
I,
ID. And two
yeah,
questions
okay,
are
okay.
there in Q&A. Should I read, sir? SPSS or R? Which one is
Yeah,
user friendly?
actually, SPS is license version. You need to subscribe. That is first one. R is usually R is some command based. So people are hesitate to use R unless and until they are not that much become a means familiar with this. So this is a Jamovi is a graphical user interface built on R. So nowadays, no need to jump to the R. You directly use Jamovi. It is open source and it is layer of R only. Okay. And developed by our community only. So it is extension of R. So it is my recommended to rather than going to any license if you do not have, then better you use Jamovi. You will get the same result in both scenario.
Then second question
Any
is
other?
from S.A. Madhavan. I
Yeah.
downloaded but cannot open. Unexpected error message is coming. Okay, this is not a question. Installation problem.
Have you installation R? You need to install R first and then Jamovi. Okay. Then you will get success. I
So,
hope you enjoy the session and I hope you share this knowledge to your scholars. So we used to start campaigning to use open source softwares in research community, whether it is statistical or library automation or any kind of scholarly communications software just like reference management and all. Okay.
sir, one more thing is there, Surabhi.
Of course. Why not? You can mention it also. Okay, I have made all the analysis using Jamovi. It is not necessary. You will. I told you there is no difference in your result, whether it is SPSS, Excel, or Jamovi or R. Everywhere it is same result you will get. So rather than going to subscribe SPSS, you can use Jamovi and mention also under that. Yeah, use Jamovi. You can cite the Jamovi website under your PhD thesis also.
Package is not important. What statistics you are applying, that
Yes,
is important.
that is important, and how you are going to interpret. Just
Yes,
like now you
that is.
directly apply t-test, but whether t-test is applicable or not. So that's what I made this decision tree.
Mhm.
If this data satisfy the assumption, then t-test is applicable.
Mhm. It is like whether you write your answer with Rotomac pen or with Reynolds pen doesn't matter. What you write, that does matter.
Correct.
So, sir,
So
one
thank you
more.
very much, sir, for giving opportunity to share this knowledge to this community. And I hope this same presentation will carry forward to their scholars. And thank you.
Sir, one question is there from Advan. Are all analysis are covered in Jamovi? Yes, SPSS.
Yes. Yes. That's what I presented last. You need to explicitly add modules
Mhm. Need
from
based.
Jamovi library. Okay, where you can find out all the.
So, sir, I hope this program is this package is not very resource hungry. Na? Simple package
Simple.
like RAM and all those. Not very high requirement is not there.
No, 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 no. It depends. Always package is always light. It depends on your data.
Hmm.
Data is large, then you require high-end desktop.
Okay, so I think, sir, no, one more question came. So please share your contact number. Already shared.
Already shared in
Already shared.
chat box.
Yeah. So and 3 day program schedule.
Not yet means announce it probably in month of September or like this. But you refer our previous year brochures, you will get it
Okay.
details over there.
Okay, sir. I think we can
Thank
conclude
you.
the session here now. We are not having more questions. So thank you, sir, for sparing your
Thank
time
you.
and explaining the things uh, with what to say with our speed, not at your speed. So thank you for your presentation, and we will request you some other occasion also to have some more presentation on such things. Thank you, sir. Thank you.
Thank you, sir. Thank you.